Welcome to part two. We are going to discuss thumb projections. Image analysis guidelines for the AP thumb projection state that there should be concavity on both sides of the phalanx and metacarpal phalanx. The metacarpal midshafts are equal. There is equal soft tissue width on each side of the phalange. The interphalangeal joint, the metacarpal phalangeal joint, and the carpal metacarpal joints are demonstrated as open spaces. The phalanges should not be demonstrated as foreshortened. Superimposition of the medial palm soft tissue over the proximal first metacarpal and the carpo-metacarpal joint should be minimal. The metacarpal phalangeal joint should be demonstrated at the center of the exposure field. The phalanges, metacarpals, and metacarpal carpo-metacarpal joint should be demonstrated included within the exposure field. The next slide provides the image analysis guidelines for you. So let's take a look at a couple projections of inadequate positioning for the AP thumb. In the first projection, we can see there's some palmar surface soft tissue overlap. If the medial surface of the palm is not drawn away from that thumb, the soft tissue and possibly the fourth and fifth metacarpals superimpose the proximal first metacarpal and carpo-metacarpal joint there, as you can see in this image. In the second image here of excessive internal rotation, that can be demonstrated when you start to see the amount of phalangeal mid-shaft concavity and the soft tissue width increase on one side of the thumb, that the anterior thumb surface rotates toward, and decreases on the side that the posterior surface rotates toward. If the arm is internally rotated more than it needed to bring the thumb in that true AP projection, the anterior surface and the greater phalangeal midshaft concavity is demonstrated on the side of the thumb positioned next to the hand on the projection. So in excessive rotation, you can start seeing that this concavity over here is growing. It is not in a true AP projection. You should have equal concavity on both sides of this thumb for it to be in a true AP projection. You can also see that the starting to see down here the trapezium coming out in profile, meaning we are truly in a excessive internal rotation here. In our last image of inadequate positioning of an AP thumb, I want to demonstrate the importance of alignment of the thumb with the longitudinal collimated field alignment. The alignment of the long axis of the thumb and the collimator's longitudinal light line enables you to collimate tightly without clipping the distal phalanx. So it's important to make sure that you adjust that collimated field to the long axis of the bone, so you don't clip the distal or the proximal metacarpal and distal phalanx. So let's take a look at a practice analysis of the AP thumb. In this projection, we can see we have some overlap here distally of some soft tissue and of some metacarpals as well. So we have some type of rotation problem for the AP projection. Also, you can see that the concavity on one side of the phalanx is greater than the other, and we want equal shaft concavity. Therefore, the fifth metacarpal and the medial palm soft tissue are superimposing the proximal first metacarpal and the carpal metacarpal joint. There is slightly more concavity, like we talked about, on that side of the thumb there, rather than it being equal soft tissue concavity on both sides of the thumb. This means that the thumb was internally rotated slightly more than needed. In order to correct this positioning error, we want to draw that medial side of the affected hand and palmar surface away from the thumb, okay? And you want to make sure that the hand stays in a true AP projection. So if you're starting to draw that medial surface of that hand away and you rotate accidentally out of AP, you need to bring it back enough to get that hand back in, or thumb back into that true AP projection. Moving on to our lateral thumb projection. Image analysis guidelines for the lateral thumb projection state the anterior proximal phalanx and the metacarpal should be demonstrated with midshaft concavity, and the posterior proximal phalanx and the metacarpal demonstrate slight convexity. Okay. When visualized, the thumbnail is demonstrated in profile. The interphalangeal, metacarpal, phalangeal, and the carpo-metacarpal joints are demonstrated as open. The phalanges should not be demonstrated with any foreshortening. The first proximal metacarpal joint metacarpal is only slightly superimposed by the second proximal metacarpal. The metacarpal phalangeal joint is at the center of the exposure field, and the phalanges, metacarpal, and carpal metacarpal joint are included within the exposure field. The next slide, you will see those image analysis guidelines. So let's talk about inadequate thumb positioning. An insufficient hand flexion, where the hand is rotated up just enough so that that thumb is in a true lateral projection. The mid shafts of the proximal phalanx and the metacarpal will show varying or equal degrees of concavity on both sides, where we only want it on the anterior side. So therefore, you may need to take a repeat image and bring the hand up so that you can get that nice convexity on the outer side of that thumb, or the nail side of the thumb, and have more convexity on this side, or concavity, sorry. An excessive hand flexion, that is the over rotation of the hand, that causes the second proximal metacarpal to superimpose the first metacarpal. So you can see down here, the second proximal is, the hand is flexed so much, it is superimposing over the first metacarpal there, and it may cause the thumb to roll beyond a lateral position and towards more of a AP oblique position. So you may need to bring that hand back down, because you want to make sure you demonstrate this trapezium out here not superimposed as the as it is in this excessive hand flexion. So let's take a look at this first, or this lateral thumb practice analysis. We can see that there is some degree of concavity on both sides of the thumb in this in this lateral projection. I'm sorry. And also utilizing what we just learned, looking down here at the metacarpal, it is not, the trapezium is not superimposed by the second metacarpal as much, which tells me that we're not sufficiently in a appropriate hand flexion. So we need to increase that hand flexion until that thumb rolls into that true lateral projection and that nail is in profile. Also, you know, look at your the condyles on the phalanx here. If they're not superimposed, then you might not be rotated up entirely enough. Let's move on to the PA oblique projection of the thumb. Image analysis guidelines for the PA oblique projection state that there should be twice as much soft tissue present on the side of the thumb next to the fingers than the opposite side. More proximal phalangeal and metacarpal midshaft concavity is present on the side of the thumb next to the fingers than the other side. The interphalangeal, the metacarpal phalangeal, and the carpo-metacarpal joints are all demonstrated as open spaces. The phalanges should not be demonstrated as foreshortened. The metacarpal joint is at the center of the exposure field, and the phalanges, metacarpals, and carpo-metacarpal joint are all included within the exposure field. The next slide provides those image analysis guidelines for you. We know that when taking the PA hand projection, the hand with sitting in its natural PA projection, the thumb is already in that PA oblique positioning where it should be. So typically, you're not going to deviate from that hand positioning. However, if the hand is not placed flat against that IR, but the hand itself is allowed to flex, then the thumb can rotate more towards a lateral projection. So you must ensure that that hand is in contact and flat against that IR to prevent from excessive obliquity, as we see demonstrated in this image. So let's take a look at this PA oblique thumb practice analysis. When looking at this projection, I can see that we have closed phalangeal joint spaces here, interphalangeal and metacarpal phalangeal. And when the thumb is flexed or a digit is flexed, that causes for shortening in the digit. So our natural thought process should go to, is the palm or surface flat against the IR? Go and check the patient, place the patient's hand flat against the IR, and ensure that that thumb is not, there isn't any tilt or anything going on with it for the projection. This concludes our image analysis on finger and thumb. If you have any questions, please feel free to reach out. Thank you for participating in the learning module.